we are talking about domain and the range of the function of different types for AS level for P1. We know that y is a function of x, and x is known as the domain, and y is known as the range. So this is the main thing that whatever the values of x you are going to put in the equation, you are going to get the values of y, then it will be the range, and all possible values of x is known as the domain. So if we reverse that thing, we make x as subject from this equation, then x is equal to f inverse of y. Then if this is the main, and this is the range of a function, then x will become the range and y will become the domain. So we interchange their positions and they are going to get this values there. Now, we are going to define each and everything of this function's topic there, one by one. First of all, the function is of three types. The first is known as we call general function. That is y is equal to f of x simple terms there. And that is written as in the form of axn plus b power xn minus 1 plus c into x power n minus 2 and so on. So this is the general polynomial. We can write it as the function known as we call polynomial. Now, it has two things in this part. One is the highest coefficient of this x. So n is the highest coefficient and a is the value of the highest coefficient. Now it has two categories. The first part is if n, it can be either odd or it can be either even. If it is odd, then the graph's ends will be in opposite direction. And if it is even, then the graph's ends are in same direction. So let's explain it one by one, and then we will define this both domain and range of this function here. For example, y is equal to axn plus something. Now, n is odd and a is greater than 0. So when a is greater than 0 and n is odd, so we have seen that it is odd, the graphs will be in the opposite direction. Now it all depends upon the value of a. So if a is greater than 0, then it is right side of graph will be upward and the left side of that graph will be downward. Now, for this, we are taking this example. Let's say y is equal to 3x1. So we have seen in this case that a value is equal to 3, which is an odd number, and n value is equal to 1, which is greater than 0 there. So it means the right side of this graph will be upward and the left side of this graph will be downward. So it is like this. This is the origin. This is the right side, which is upward, and this is the left side, and that's downward. Similarly, if we are going to draw the graph of y is equal to 2x cubed, in this case, n is 3 and a is the coefficient of the school. So this means the graphs will be in the opposite direction. And for this case, this is the origin, that it is passing from this point. So you have seen it here, that this is upward and this is downward. So we see that in this cases of these two, that n is odd, and we are wanting coefficient of this like this. Upward is the right side and downward is the left side. But if the same case is there, then y is equal to minus 3x over 1, where a is equal to minus 3, which is less than 0, and n is equal to 1, which is an odd number. So right side will be upward, downward, and left side of that graph will be upward. So keeping this in view, this is the graph of this portion. This is the graph of this. So you have seen it clear that the left side is upward and the right side is downward. So if we take the other example of this, that y is equal to 2 minus 2x2, then here n is an odd number and a value is minus 2, which is less than 0, then the left side of this graph will be upward and the right side of this graph will be downward. That is upward and the left side of this graph is downward. It is passing from this origin. So you have taken this example into your mind. Now, the range of this graph will be all real numbers. So the name is of this graph is belonging to all real numbers, and the range of this graph belongs to all real numbers. Because you keep on extending x on right side, then it will be going up or down, and you keep on extending the left side, it will be coming up and down. But we have seen it there that they have no restriction on this. But if we restrict the graph, the domain is restricted here, then the range is also restricted. So if domain is restricted there, then the range of this graph is also restricted. So this is the case when it is in the form of the general polynomials. Then the graph nature will let you know that if it is not restricted, then its range will be all values, and if it is restricted, then the range will be restricted to that value there. For example, you are making this graph from 1 to minus 1, then at one value, this value will be equal to 3, and for minus one value, it will be equal to minus 3. So now the range will be from minus 3 to 3 here. But if it is not restricted, then its range will be on real numbers. So this is the first case when it is in the form of the general polynomial there. Now, if n is an even number, when n is even number and a is greater than 0, then both ends of the graph will be upward. And if n is even and a is less than 0, then both ends of the graph will be downward. Now we take the example of this case one by one. Let's say y is equal to 3x squared. So here it is an even number and this a is greater than 0. So both ends of the graph will be upward there. So this is the nature of this graph. Draw this graph. Then both ends of the graph are upward. So, but it means that the domain is belongs to all real numbers, but range of this graph is always restricted. Why it is restricted? Because this graph will not go less than 0 to that validation. So whenever it is an even number, then you have to see that the domain belongs to the all real numbers, then the range of the graph will always be restricted. It is either upward, below, or in simple words, we can say that it is greater than or equal to 0 value for this case. And if we draw the graph of y is equal to 2x 4 plus something like that, then again this is an even number, this is the coefficient of that is positive. So the graph of this will be upward there. So that means both graphs are going to be upward, but the range of this graph is restricted there, which is greater than or equal to 0. For example, we take this example of 2x squared plus 3, then the graph of this will be plus 3 is the y unit there. So it is like this. So you have seen it in this case that the domain is belonging to all real numbers, but the range of that graph is greater than or equal to 3 value there because it is more than 3 value there. So this is the way that we can find out the domain and the range of this given function there. But if it is even and it is less than 0, then both ends of the graph will be downward. For example, y is equal to minus 2x squared. Then this is the graph of that which is coming, both ends are this downward. So domain of this graph belongs to all real numbers, but the range of that graph is restricted. That means it is less than or equal to, in this case, 0 value there. A range is always less than or equal to that value there. So this is the graph of the even function when power is even and the coefficient of x is either positive or negative. If it is positive, then both ends will be upward, and if it is negative, then both ends of the graph will be downward to that. Same case, we can write it like this: y is equal to minus 2x squared minus 1. Then this is the graph of this minus 1. Both ends are of this graph are downward to that, and the range of this function is less than or equal to minus 1, because all values are less than this minus 1 value here. So this is concept about the general polynomials when the highest power is odd or even and the coefficient of highest power is either positive or negative. So this is a way that you can find out the Cauchy's domain and the range. And now the second case we are going to define it here. That is known as the surd function. Surd function means what? Y is equal to f of x power n. So n can be either odd or it can be either even. F of x is the general function of this quotient. So, for example, we are going to draw the graph of y is equal to square root of x. Then this graph will be like this. It is 0, it is x axis, it is y axis. So, domain of this graph belongs to that x value should be greater than f of x value should be greater than or equal to 0. And the range of this graph will also be greater than or equal to 0 value. Why? We know that the square root of 4 value is positive 2. Square root of 9 value is equal to positive 3. So you have seen it there that it is only the square root. When it is a positive value will be taken, and it will be positive 2 and positive 3 for 4 and 9 value. So when f of x is greater than 0, then base is also greater than or equal to 0. If f of x is negative, this negative means what? Less than 0, and the function n is their even value, then main is not possible. So we will be no domain of this function y is equal to minus x square root, because the negative values of square root is not possible. But if it is n is an odd function, y is equal to x we will use simply become x power 1 by 3. Now if we draw the graph of this, then it is the graph like this. This is y is equal to cubic root of x there. So you have seen it in this case that the domain belongs to all real numbers, and the range is also belongs to all real numbers. Because on this side, if x is positive, it will go to this positive side, and if it is negative, then it will go to the negative side. For example, we know that the 8th cube root is basically equal to 2, and minus 8 cubic root which is equal to minus 2. So when it is cubic roots or odd roots, for positive value it is positive answer, and for the negative values it is the negative answer to that. So same is the case for this domain, and if domain belongs to all real numbers, then the range is also belonging to all real numbers. So if simple words, if domain is belongs to positive real number, then the range of this graph belongs to the positive real numbers. In other words, if domain belongs to the negative real numbers, then the range is also belonging to the negative real numbers. So this is the case when it is having an odd function and when it is having an even function. So that is the second case when it is defined for the third function, then y is equal to f of x square root of n bit. Then the third function is there. Which is known as called the rational function. Which is given like this g of x over f of x given in the form of the fraction here, where f of x should not be equal to 0. So we can see that the domain of this function will be equal to f of x not equal to 0, and the range of this function will be except infinity all values are possible. For example, y is equal to 1 over x, where x is not equal to 0. The domain of this function will be x is not equal to 0, and the range of this function, draw the graph of this. So you have seen that it's not equal to 0, and the rest of the all possible values are possible for the range of this function. For example, y is equal to 1 over x minus 1. Then the domain of this function will be x minus 1 should not be 0, or x should not be equal to 1. So at one value it is not possible, but the rest of the values it is possible. And if we have to draw the graph of this one, so it is a graph like this. So it means the range of this graph will be not 0. Rest of the values are possible here. Range is what the values of y, and y value cannot be equal to 0 in this case here. So these are the three types of the functions which you are going to study in this topic of the function levels for the simple function, and we can find out the domain and the range of these calls.